So in this video, I'm going to go through the 4 problems you were assigned from the quadratic formula worksheet. One of the things you have to understand about the quadratic formula is that it must be written and set equal to a value of 0, so you can establish the correct A, B, and C value. In the problem numbers 3 and 4, you'll notice that you have x and x squares on different sides of the equation, which means the A and the B values will be incorrect. So quadratic formula is based on being set equal to 0 because we're trying to find the points of intersection with the y-axis. That's where y is equal to 0. So the quadratic formula, I always recommend writing down the formula. I generally leave blanks where the number's supposed to go. But graphs math actually has a function here that will set the problem up. So the b value here is supposed to be the opposite of b. So it's positive 11 in the original equation, so it becomes negative 11. Plus or minus b squared. I do recommend putting parentheses around this number, just get in the habit of doing that. It doesn't change anything if it's positive, but if it is negative, the answer is supposed to be a positive answer. Minus 4 times the a value, which is 4, times the c value, which is negative 20, all over 2 times the a value, which is 4. The denominator is pretty easy to do. This is a two-step problem. I recommend doing the discriminant next. Try to get down to a single value, and then you can evaluate from there if the solution is going to have a really nice decimal answer because the square root happens to be a perfect square, whether the square root can't be simplified, or if it does have a simplified value, it's still going to remain as a part of it as the square root, or if there's no solution at all, which means the answer is negative. So take care of the discriminant first. So if squaring, this first problem, we have multiplication next. So hopefully you found this answer to be square root of 441. And if you check the calculator, you'll find that the square root of 441 is actually 21. So this one came out to be nice. Now the plus and minus indicates to us there's two answers. So if I split the problem into two problems, I'm going to be doing an addition problem as one solution and then the subtraction as the second solution. So addition gets done first, and then the final answer here is 5/4. So the parabola will intersect the x-axis at 5/4 comma 0, or 1.25 comma 0. And then the other solution is negative 4. So it's negative 4 comma 0. The other conversation I've had with my other classes about the quadratic formula is not only do I know where the graph is crossing the x-axis, if I go back to the original equation, this number again, the c value, tells me where it crosses the y-axis, which is 0 to negative 20, and the quadratic formula, this opposite b over 2a part right here, this actually is the h value of the vertex. So we know the vertex is at negative 11/8 comma something. So if I stuck this back into this problem here, I could actually solve for y, and then I would have all 4 critical points. So the quadratic formula, going from standard form, will provide us actually, I'm going to call it 3.5 points. 3 complete points if the graph crossed the x-axis, plus the y-intercept, and the h value of the vertex. So in problem number 2, again, set equal to 0, which is a requirement. Using the quadratic formula, this time the b value here is 5 because it's the opposite of the b, so the b value is negative 5, so it's going to be 5 here, plus or minus. Again, make sure this is in parentheses, and I recommend whether it's positive or negative, always get in the habit of putting this in parentheses. So b squared minus 4 times the a value, which is 1, times the c value, which is negative 24, all over 2 times the a value. The denominator is a quick one. Again, I'm suggesting the discriminant next. Try to decide if it's a perfect square, is it a square root that we can simplify that's not a perfect square, or no solution because we get a square root of a negative answer. So in simplifying this, hopefully you found your answer to be the square of 121, which happens to be a perfect square. Because of the plus and minus, we have two possible solutions. So completing the one on the addition problem, hopefully you got an answer of 8, and completing the subtraction problem, hopefully you got an answer of -3. So the parabola crosses at 8, 0, and as well as -3, 0. The graph crosses the y-axis at 0, -24. And the vertex is 5/2, comma something. And again, we can stick 5/2 back into the original problem and make this a y, and we can solve for the y value to get the fourth and final point. Right, in problem 3, this is where we need to rewrite the equation. I always evaluate whether I'm going to move the x square or leave it where it's at. If the number in front of the x square is a positive number, I leave the x square where it's at, and I make the other side equal to 0. So to do that, we need to subtract the 3x plus 3 from the left side. So we're going to subtract 3x and subtract 3 from both sides to get the equation I'm looking for the key that allows me to move it. So give me a moment. There we go. So this is the correct form we need. So the A value is going to be 1, B is -3, and C is -3 as well. So using the quadratic formula, the 3 is going to become positive 3 now. On the outside, containing the opposite of B, -3 squared minus 4 times 1 times -3, and then divide by 2 times 1. In simplifying it, again, take care of the denominator first, and then take care of the discriminant next. What we're trying to get this down to is a single answer, and decide whether or not the square root itself is something that we can simplify. In this case here, it's not a perfect square, so you have to evaluate the factors of 21, which are 1, 3, 7, and 21. Only 1 is the only perfect square factor, so that means that based on the work we did on earlier this week with the graceful math activity, this square root cannot be simplified. So these are the two solutions, 3 plus the square root of 21 over 2, comma 0, and 3 minus the square root of 21 over 2, minus 0. If we're going to graph it, then we would definitely turn these into decimal numbers so we have some idea of where it's crossing the x-axis. 3/2 is the x value of the vertex, and the when we wrote this here, it was a -3 on the other side here, and so the y-intercept is 0, comma -3. In the last problem, again, the value in front of the x squared is positive, so I would leave everything on the left side alone and add 5x to both sides to get this problem in the form of ax squared plus bx plus c equals 0. So using the quadratic formula, the b value is going to be the opposite of b, so it was 5 when I added it to the left side. So it becomes -5 here, plus or minus 5 squared minus 4 times the a value, which is 1, times the c value, which is 5, all divided by 2 times the a value, which is 1. Again, I get that denominator completed first, and then I complete the discriminant to see what kind of answer you come up with, and we end up with 5 under the radical. Square root of 5 itself has only 2 factors, 1 and 5, and so we again, in terms of factoring, we ignore the 1. So 5 does not have any perfect square factors other than the 1, so this cannot be simplified any further. So these are the two answers. Again, if we want to figure out where it crossed the x-axis, we would simply turn the square root into a decimal number and then simplify the problem. So this parabola is going to cross the x-axis at about 1.38. And then in the other solution, it cross the x-axis at about negative 3.618. And again, the h value would be, the vertex would be at negative 5 halves or negative 2.5, which should be exactly between these two. So if you took these two answers and added them together and divided by 2, you should get negative 2.5, which is the h value. And then the y-intercept is 0.5. So hopefully, any problem that you missed, hopefully you can go back and revisit those problems and redo them. And then on Tuesday next week, we will continue with our work with quadratic formula, and then we will also be introducing a new number system into this formula by trying to address what happens when we have a negative square root. Is there an actual solution?